You're still gonna need your laptops because we got to do this. We got to do the stack crunch activity. Okay. All right. This is a very important. The next figure is very important because we're gonna see this again at the end of the semester. We're gonna see this in a later chapter. Okay. So it's very important to pay attention to this. So this is a contingency table. This is another way of summarizing data. You can, so a contingency table is now where, if you wanted to look at it, we had two variables of interest. And these A1 and A2 are the outcomes, for example, for event A. And then here's another, these are the outcomes for event B. So these are possibilities, possible outcomes. These are possible outcomes. Keep in mind that this is just an example. I'm not saying that all contingency tables look like this. Okay? You could have had maybe, for example, 4 rows and 3 columns or something like that. Okay? But nonetheless, this is a contingency table. It's a tabular matrix filled with either counts, proportions, or percentages. So here we got proportions, right? But you could put counts in there. And even if I use counts, the pedagogy that we're going to talk about for calculating probabilities is still going to be the same. Okay? So, for example, like I said, these are proportions. This 0.33 is the intersection of A1 and B3. So, for example, that is, we can use that as a probability. We would say the probability of A1 and B3 is 33% or 0.33. Is everybody with me? So the intersections, the outcomes that deal with that is the probability of the intersection of those, or the probability of A1 and B3 happening. Okay? So like, for example, this 0.2 is what is the probability of A2 happening and B2 happening, for example. We say it's 20%. So I'll put that up on the board. This is, okay? Of A, what does I say? A2 and B2 occurring, that would be 20%. Is everybody with me so far? All right. Now, in a contingency table, you could make row totals and column totals. I don't recommend doing that, okay? Because if you put row totals and column totals, some of y'all gonna mess up and forget the pedagogy. So I would recommend don't putting row totals or column totals, okay? Leave it like this, okay? And I'll give you an example. Oh, by the way, when we talk with the contingency table, we can talk about the dimension of a contingency table. This is an example of a 2x3 contingency table. 2 rows, 3 columns. So it's the number of rows by the number of rows by the number of columns. Is everybody with me? So this is a 2x3 contingency table. Okay. If I had, like I said earlier, if you had 4 rows and 3 columns, this will be a 4x3 contingency table. Okay. You do not include, if let's say a contingency table has a row totals or column totals, you don't count that in determining the dimensions. So if I had a row here that was the sum of the probabilities going down, you wouldn't count that as a row. It'll still be a 2x3 contingency table, for example. All right. So that's the dimension of how to determine the dimension of a contingency table. So look here. This is a perfect example of what I was telling you. Okay. So you see, there's a row total and there's a column total. You don't include that when you talk about the dimension of a contingency table. Is everybody with me? So there are 3 rows and there are 2 columns. So the dimension of this contingency table will be what?
3 by 2.
3 by what? 2. Is everybody with me so far? 3 by 2. You don't include the row totals and column totals. And so you would use this piece. This is like your sample space. View this table, this piece as the sample space. Again, don't look at the row totals or the column totals. This is the sample space. This is what we're going to use to calculate the probabilities. Is everybody with me so far? All right. Okay, so let's look at our scenario and watch how we answer these probabilities. We're going to use the same pedagogy that we just applied like we did with the contingency tables, okay? So the showcase showdown determines which of the 3 contestant winners who won their way up on stage goes to the showcase at the end of the show. The 3 contestants are in position by how much they won thus far. So they put them in line based on who won the least amount to who won the most amount. Is everybody with me? The person who won the least amount gets to spin first. And the person who won the most spins last, okay? Below is the contingency table analyzing how well contestants in a particular position win the showcase showdown, okay? So for example, looking at the last, let's say 150 showcase showdowns, there were 8 contestants that spun first and what? Won the showcase showdown and went to the showcase at the end of the show. Is everybody with me? So this 42 says that there were 42 contestants that spun first, but they did not win. Is everybody with? They didn't win the big wheel, the showcase showdown. Okay. So remember, this is what we're going to use to answer probabilities. Okay. The totals, don't worry about the totals. Just these. Is everybody with me so far? All right. Calculate the probability that a contestant is player 2 and wins. Okay? Now, because, let me erase this. Bless you. So, because these are counts, you can convert them, you can, stay right there, you can convert them to something like this. You can convert them to proportions by simply taking each of these counts or frequencies and divided by the grand total. Is everybody with me so far? So I'm going to, okay, I'm gonna lift this up. Okay, I'll lift this up. Y'all please don't, y'all watch me. Please don't let me write on the wall, okay? Because I will get in trouble. The department chair will not be happy, okay? So I'm gonna write here on the side the proportion. So to change these two proportions, you divide by the grand total, which is 150. Is everybody with me? So can somebody do 8 divided by 150? Or 8 divided by 150? 0538? 33. Okay. And what's 42 divided by 150? Somebody go ahead and start on the second row for me. What's 42 divided by 150?
0.28.
Point what?
28.
0.28?
Yes.
Okay. Okay. 23 divided by 150? And somebody go ahead and start working on the third row. 23 divided by 150 is
0.1533.
33?
Yes.
Okay. 27 divided by 150?
0.18.
0.18 even?
Yes.
Ooh, okay. Nice. Yeah, because they're both, yeah, that makes sense. They're both divisible by 3. So 3 over 50. What's 3 over 50? 6. Oh, okay, whatever. 9 over 50, which is, yeah, you're right, 0.18. 39 divided by 150?
0.26.
0.26 even?
Yeah.
Ooh, okay. I like when stuff comes out nice and even. And 11 divided by 150, 0.07.
0.7, no,
0.0733.
Okay. This is a point of this. Okay. All right, good. All right, so calculate the probability that a contestant is player 2 and win. Do y'all understand where we got these proportions from? You take the frequencies divided by the grand total, okay? All right. Calculate the probability that a contestant is player 2 and wins. So player 2 and wins. So what is that answer? 0.1533. That's right. So the notation is what's the probability that you are player 2, so A2, and, which is the and, wins, which is B1. So we said it was what? 0.1533?
Yes.
Good.
When you write the answer, do you just write it like that? It's not P and then the answer equals the answer?
Mm-mm.
Okay.
I want you to write out the notation. Okay? Convert it to, this is called converting to symbolic notation. I'm using symbols to represent the words. Is everybody with me so far? All right. What about this next one? Calculate the probability that a contestant is player 1, so that's A. Probability of A1, right. And does not win, so that's what?
B2.
B2, right. So, first player and does not win. So you should tell me what?
0.21.
0.28, 28%, that's right, 0.28. And you know it ain't that simple, okay? Now, what about this one? Calculate the probability that the contestant wins. So wins is what? What is win?
B1.
B1, right. So you're just finding the probability of B1. So you go, again, this is what we're playing with, just this, okay? So if it has something to do with B1, I want it, right? So it's gonna be what? Do we have, is that pointing to one particular probability? No, 3, which ones?
All of B1.
Column B.
Yeah, everything in this column, right? The B1 column, which is this one, 0.0533, 0.1533, and what? 0.26. So I'm gonna add them. Same pedagogy we did with tree diagram, okay?
Are you doing that second question?
I'm doing this one,
Oh,
yeah. So 0.0533, 0.1533, and what? 0.26? Can somebody give me a total?
0.4666.
0.4666?
Yep.
Yeah? Okay, very good. So a little over 46%. Okay. Now we got to go into conditional. We got a conditional probability. We see the word, why do we know it's conditional? Because we see the word given. What's the other word you can look for? Of, thank you. Given or of. One of those two, you go with conditional. Okay? All right. So, it says, calculate the probability that a contestant is player 3. Player 3 is what? A3?
Yes.
Okay, given, so we're going to do the vertical line. The contestant wins. Wins is what?
B1.
B1. Because it's conditional, what should we draw? Fraction mark, correct. I'm going to put in the denominator those probabilities from the table in the center of that table. They have something to do with B1. So tell me the ones that go in the denominator.
0.533.
0.0533, what else?
0.1533.
Thank you, 0.1533, and what else?
2.26.
And 0.26, correct. Now, of these three, of those three, which one or which ones have something to do with this?
0.26.
Right, the last one, 0.26, correct. Is everybody with me? And then from there, yep, use your calculator and throw that bad boy into the calculator. So
0.557.
0.26 divided by. Okay. Did you get 5572?
Yes.
Yes.
Yeah. Okay. of those that won the Showcase Showdown, 55.72% of them spun what? Last. Is everybody with me? Because there's only 3 contestants, so A3, if you spun third, you spun last. So those of you that know about the show, that's the reason why they put the person last, the person who won the most money last. Okay? Because that's an advantage. You get an advantage. All right. Questions?